So let us proceed. Question number 1. Which of the following charge is not possible? Which of the following charge is not possible? If it is possible, then how to develop this charge? So it is a conceptual question about the charges. So there are two values which are given to us. One is 10 raised to the power minus 20 coulomb and the other one is 10 raised to the power 20 coulomb. So can you create a charge of 10 raised to the power 20 coulomb and 10 raised to the power minus 20 coulomb? So what is the problem? Is there any problem you can see that you can make this charge or not? So can you think about it? Is there a way to develop this particular charge 10 raised to the power minus 20 coulomb or this particular charge? So where is the problem? The problem is that the minimum possible value of the charge is the electronic charge. So it is 1.6 into 10 to the power minus 19 coulomb. It is the minimum possible charge that can exist independently. And here it is 10 to the power minus 20. So existence of this charge is just not possible. Have you got the idea? There is a minimum limit to the charge, and here the required charge is even less than that particular minimum limit. So we cannot create this charge. So that was the question. Which of the following charge is not possible? And of course we can develop the 10 to the power 20 coulomb, although it is a very large amount of charge. But we can develop. How many electrons are needed to be transferred? That you can easily calculate by 10 to the power 20 divided by 1.6 into 10 to the power minus 19, which is charge on single electron. So this charge is possible, theoretically at least, but this is not possible at all. The one point that I would like to add here is that this particular charge is very, very large amount, although its existence is possible theoretically. How it is a large amount of charge? Just consider 1 coulomb. Just try to figure out how to create 1 coulomb charge using the frictional electricity. How many electrons are needed to get transferred from the body in order to generate 1 coulomb charge? As we know that electronic charge is 1.6 into 10 raised to the power minus 19, and suppose n number of electrons are needed to be removed to generate this 1 coulomb, then number of electrons will be 1 upon 1.6 into 10 raised to the power minus 19. So just calculate this value. So what are you getting? Just say 1 over 1.6. Just calculate it fast. Okay, we are getting 0.625 into 10 raised to the power plus 19, because this is going up. So it is 6.25 into 10 raised to the power 18. Can you imagine this number? What is this? Billion, trillions and trillions of electrons are needed to be removed in order to create 1 coulomb charge. So you must have got the idea that how big is the coulomb. That is why in most of the numerical problem you'll encounter the units of charges as microcoulomb or picocoulomb, like that only. Micro means 10 raised to the power minus 6. Pico means 10 raised to the power minus 12. So such units of charges are normally used because coulomb is a very big unit of charge. That you can infer that 6.25 into 10 to the power 18 electrons are needed to be removed or added to a body to generate a charge of 1 coulomb. There is one more way to understand its quantity, that how big is 1 coulomb. Suppose there is 1 coulomb charge and there is another 1 coulomb charge, and both are suppose kept at a separation of 1 meter. Then according to Coulomb's law, what will be the force acting between these two? So F will be 9 into 10 raised to the power 9 into Q1, which is 1, into Q2, which is 1, divided by distance square, which is 1. You remember the formula, Coulomb's law, that we have just read just now. It is K into Q1, Q2 divided by R square, where K is 9 into 10 raised to the power 9. So here it is. So force is 9 into 10 raised to the power 9. So 9 into 10 raised to the power 9 Newton. So just feel that what is this amount. Suppose there are persons of 100 kg each, although it won't be easy to find many people who are 100 kgs. So just assume that we have several people of 100 kg mass. Then what will be the weight of a person? It will be multiplied by g, acceleration due to gravity. Just assume it to be 9. So 1000 Newton. So if you want to lift one person of mass 100 kg, then how much force is needed to lift that person? It is 1000 Newton. So here the force is 9 into 10 raised to the power 9. So how many such persons can be lifted with this force? So you can divide by 1000. So you are getting 9 into 10 raised to the power 6. So 9 into 10 raised to the power 6 means 9 0 0 0 0 0 0. So what is this? 90 100,000 means 90 lakhs. So 90 lakhs of such people who are 100 kg can be lifted by this force. So you can understand how big is this amount. So you got the idea that 1 coulomb is a very big unit of charge. That is why we normally use microcoulomb, millicoulomb, picocoulomb, etc. So let's proceed to the next question. Find the minimum electrostatic force acting between two charges at a separation of 1 meter. So suppose there are charges Q1 and Q2 at a separation of 1 meter. So according to Coulomb's law, force acting between these two will be K into Q1 Q2 divided by R square. The value of K we know is 9 into 10 raised to the power 9 multiplied by Q1 into Q2 divided by square of the distance. Distance is given to be 1 meter. So 1 square. So we have to find the minimum possible force between two charges which are kept at a separation of 1 meter. So the result is dependent on Q1 and Q2. So we have to think about the minimum possible value of Q1 into Q2. So can you figure out the minimum value of the Q1 into Q2? Just now we have discussed the same thing, that there is a minimum possible charge which can exist independently, which is charge of the electron. So what is the minimum possible value of Q1, Q2? Suppose both the charges are having the charge equal to that of the electron. That is the minimum possible. So Q1 into Q2 will be 1.6 into 10 raised to the power minus 19 into the same means square. So it becomes 2.56. I suppose you can calculate it later on, minus 38. So we can use this value here to find this force. So here you can see that quantization of charge is something which is asked indirectly in this question, that there is a minimum amount of charge which can exist independently in the nature, and that charge amount is the charge carried by one electron. So we are using the minimum possible values of the charges to get the minimum possible force. So now let us proceed to the next question, the question number 3. There are 3 identical charges Q. Each are kept at vertices of an equilateral triangle of side A. Means there are 3 charges. One is here and other one is kept at this corner and the third one is here at this corner. And the size of this triangle is given to be A by A by A. It is an equilateral triangle of side A. So we have to find the force on any of the charge by the other 2. So suppose we are going to find the charge on this force on this charge kept at C. So force because of charge A. These are point charges, and direction of force will be along the line joining the charges according to attraction or repulsion, whichever is the case. Here all the charges are similar, so there is a case of repulsion in both pairs. So point C, the force exerted by the charge at A will be along this line, and it is repulsive, so this way. So it is Fa. And similarly, the charge B will apply force acting along this line, and it is repulsion, so this way. As charges are same, distance for these two pairs are also same, so magnitudes of Fa and Fb are same. What is that magnitude? 1 upon 4 pi epsilon naught into Q1, Q2 is Q square divided by square of the distance, which is A square. So force between the two pairs is Q square divided by 4 pi epsilon naught A square. So these are the two forces. So we have to find the resultant force acting on this particle. So when two equal forces acts on a body, then the resultant is always along the angle bisector, or we can use the parallelogram method to find the resultant, which will be along the bisector. So it is going to be what? F net is equal to under root of F square plus F square plus 2 times F into cos of the angle between the two forces. Here F stands for this value. It is say F. So we can use this value later on, but for now you have to tell that what is to be written here for the angle between the forces. Since it is equilateral triangle, so you can easily tell what is theta. So what is the value of the theta for equilateral triangle? It is 60 degrees. So vertically opposite angle, this is also 60 degree. Since both the forces are equal, so resultant is going to be at an angle of 30 degree with any of these two forces. So 30 or here 30. So we can write it here cos 60. So cos 60 is what? Half. So it becomes under root of F square plus F square plus F square. So it becomes F under root 3. So net force acting on any of these three particles due to the rest two charges is going to be Q square under root 3 divided by 4 pi epsilon naught A square. So this is the net force acting on any of the particles. One more thing, suppose we draw angle bisectors for this triangle, all the three angle bisectors, then they are going to meet at a particular point, which is the centroid of the triangle, and we extend any of the bisectors. It must be perpendicular to the side and it must be equally dividing the two sides. So this length is a by 2 and this is a by 2, and this particular line must be parallel to the net force. Are you getting my point? So here it is a by 2 and these are angle bisectors. So this angle is 30 degree. If we need this distance, say it is x, so it will be same for all the charges, all the corners. So say it is distance x, then we can use the right angle triangle trigonometry using what? Cos of the 30, because base length is known to us, so we can find the hypotenuse using the cos of this angle. So cos 30 degree will be what? Base length a by 2 divided by x. So distance of any of the corners from centroid of the triangle will be x equal to a by 2 divided by cos 30. So cos 30 is under root 3 by 2. So it is a by root 3. distance of the centroid of the triangle from one of the corners is a by root 3, and I'm sure some of you must have been remembered this value. So x we have calculated. And the other requirement of this question is that how the system can be held in equilibrium. As we have already calculated the net force acting on this particle, this charge, because of the rest two charges. It is coming out this way and with magnitude this. So to hold this charge in equilibrium, we need another force equal in magnitude to this force in opposite direction. So suppose we use a charge q dash at the centroid. So it can attract this charge C in this direction, which will be opposite to the resultant force F. And it will be acting the same way for the rest two charges also. Means if somehow we can hold the charge at C in equilibrium, then automatically the two charges A and B will also be in equilibrium. So let this charge is q dash, negative charge. And the force between these two, q dash and the charge at C, will be what? Say it is F dash, it will be equal to q dash divided by 4 pi epsilon naught into x square. So x square is a by root 3 square. So this force becomes what? 3q dash divided by 4 pi epsilon naught a square. So this is the force. And we have already taken it to be negative. And if this magnitude of force becomes equal to this net force, then our purpose will be solved. So we will put this value equal to q square under root 3 divided by 4 pi epsilon naught a square. So by equating these two terms, these two are cancelled, and here 1q and 1q gets cancelled. So 3q dash is equal to q root 3. So q dash becomes q by root 3. So it is q by root 3. So to hold this system into equilibrium, we can put a charge minus q by root 3 at the centroid of the triangle. This way, all three charges will remain in equilibrium. You can see that it is a symmetrical situation for all the charges. If we would have calculated the same thing for the B, then the result would have been the same. So just because it is centroid, so it is a symmetric location for all three corners of the triangle. So if one charge is in equilibrium, then rest charges will also be in equilibrium. So answer to this part of the question, that how the system can be held in equilibrium, is that we can put a charge minus q by root 3 at the centroid of the triangle. And first part was find the force on any charge by the other two. So its answer is this. So first answer is F net q square root 3 upon this, and the second answer is minus q by root 3 at the centroid. So that is how we can use the Coulomb's law. So in this question, you have seen that Coulomb's law is used and vector method is being employed to calculate the resultant force on a particle. So in later sessions, we'll include more complex problems along with this. So that is the end of this first session on electrostatics video tutorial series. Thank you.